Today we're looking at a problem with the campus fleet. We're looking at a way to reduce the usage of petrodiesel and to solve an environmental issue. So today we're going to be talking about biodiesel and a student operation that could solve our problems. Eagle Diesel is a student company that started here at Brockport in the Business and Economics Department. We started out right here in the lonely halls of Hartwell, working with business and economics students, finance and marketing students. But we found out very quickly that we needed a few more people to help us out. So we came to the ghostly halls of Smith and Lennon to recruit some environmental scientists and some chemists who could work on the research and production processes that were associated with making the biodiesel. So what's the point of all this? Why are business students working with the science folk? We're doing it because there's a major problem, not only here at Brockport, but at campuses across the nation. And we believe that we have a solution. There's a major waste stream on campus, approximately 4,000 gallons of it to be exact. We're talking about waste vegetable oil, the used dirty oil from cooking the food you eat here. But what's the problem with that? The problem is that this waste is hauled away to be processed and used elsewhere. But we have the means to make the biodiesel from it right here on campus and to use it right here on campus. And that's what Eagle Diesel, a student-operated company, aims to do. So using this processor, we believe our students can produce over 2,400 gallons a year for the campus when at maximum capacity. That's 2,400 gallons of biodiesel converted from waste vegetable oil that will replace 2,400 gallons of petrodiesel. And this here is the chemistry process in brief. So the first step in the process is filtering the waste oil. Most of that is done by Bask. After that, we settle all the water out. And once the water's gone, we clean the oil through the biodiesel machine. We dry it with heat and we stir. After that, we move into the chemical processes where we add in sulfuric acid, methanol, and KOH to initiate the chemical processes that will create biodiesel. These are known as reactions 1 and 2, and this creates a byproduct of glycerin. We allow the glycerin to settle, we drain off the glycerin, and then we test the entire batch for completion. After that, the biodiesel goes through a wash cycle where it's removed of any impurities. And then we pump out the finished fuel, add an oxidizer to stable the process if needed, and then we administer the fuel to the vehicles on campus. We believe that we can safely and effectively use B20. And what that is, that's a blend of 20% of our biodiesel, 80% of petrodiesel. And that prevents weather issues, and that provides us with a clean burning fuel source. And the best part about that is facilities uses approximately 9,000 gallons of fuel every year, and that's just for off-road equipment such as this alone. If we can produce 2,400 gallons, that means that we can make B20 throughout the entire supply. And that's good for us as a college, that's good for us as a community, and that's going to earn us 2 points on the STARS report for the university. So Eagle Diesel as a student company proposes significant economic value for the campus. We believe that we can save them approximately $6,000 a year. But we also propose significant marketing value for the college. But beyond that, what's most important is the environmental and health benefits that we can realize from using biodiesel, not only at the campus and in our community, but hopefully at a larger scale across the nation, across the state. So the best thing about biodiesel is the fact that it's 100% biodegradable, non-toxic, and an organic substance. That means that it's safe for us, it's safe for the environment, and it's going to create cleaner, safer, healthier air. Biodiesel, when used, produces 80% less emissions, and that's looking at the entire production process and the burning process. Waste vegetable oil biodiesel has a typical primary energy ratio of 4.25 to 1, meaning that for every 1 unit of energy that is put into the process of creation, 4¼ units of energy are available in the final product. Even better than that is the fossil fuel energy ratio. That ratio is 7.8 to 1, meaning that for every 1 unit of fossil fuels that goes into the process, we're diverting 7.8 units in its usage. So as students and faculty here at Brockport, the ball's in your court now. It's up to you guys to support programs and efforts such as this to make our campus more sustainable, more environmentally friendly. We have the resources and we have the ability to launch projects such as this. And the fact of the matter is that we can do it efficiently and economically. We've truly proven that green is gold here at Brockport, but it also looks like gold is also green. Thank you.